In this video, we're going to be looking at transformations of rational functions, in particular transformations of this function 1 over x. But first, let's look at this situation. Let's say that we have f of x be 1 over x. What would f of x minus 2 look like? So we've seen this before in composite functions. So we would say instead of x, we would place x minus 2. So again, f of x is 1 over x. Therefore, f of x minus 2 would be 1 over x minus 2. Just a quick review on that. Now, the main objective, the main topic for this video is again transformations of rational functions. So our function again is 1 over x, and just so we have a visual to go off of, we know that this function has this shape. Okay? So yes, we have a vertical and horizontal asymptote, but we're going to be taking this graph, shifting it, reflecting it, different ways. I want to begin by saying that all of this is very similar to how we transformed, x squared, absolute value of x, natural log of x, square root of x, e to the power of x. All of those transformations and how we applied each of them is the same. So when we wanted to do a vertical shift, say up 3, for the quadratic function, we would take x squared and simply add 3 to that. Well, the same can be said about 1 over x. So if I want to apply a vertical shift up 3, I would say 1 over x plus 3. And that applies a vertical shift of 3. So imagine I want to do a horizontal shift. Let's go left 4. So where we added or subtracted a number on the outside to go up or down, to go left or right, we applied the transformation on the inside. So we would have x plus 4 squared, and that gave us a shift left 4. So over here, actually before I write this down, one might say that if f of x is x squared, this would be f of x plus 4. And then you can kind of therefore see why I first went over this example. So if I have 1 over x, f of x plus 4 would appear as 1 over x plus 4. And that would give us a horizontal shift of left 4. So that would take our graph and move the vertical horizontal asymptote left 4. And I'm saying this, I'm realizing the horizontal asymptote is going to remain at the same location. With this shift, only the vertical is changing. Just something to note. But let's say I want to reflect now. So let's say we want to reflect over the x-axis. So thinking back, to do this, we applied a negative on the outside of our function. So doing the same here, negative 1 over x. And that would give us a reflection over the x-axis. That would take our graph and reflect it so that this portion is now below and this is above, by simply placing a negative in the front. So all of these changes are the same, regardless of the type of function. So if I want to apply a vertical stretch by a factor of 3. So vertical stretch, that was, just multiplying by 3. And the same, again, just multiplying 1 over x by 3, or it will most often appear as 3 divided by x. Okay? So this is, we would think about this if I was asked to take my function 1 over x and perform transformations on it. So we see really how we apply the transformations is the same as we've seen before. Nothing has changed. But what if I want to look at a function and describe what transformations occurred? So, we want to describe the transformations applied to 1 over x. I should say, whenever I apply transformations, it will take this function and give it this appearance. Not every time, but this is the type of rational function we achieve. So notice, we have both linear polynomials. We can never take 1 over x, perform a transformation, and get from it a quadratic, cubic, or a higher degree. We can only apply a transformation and get linear polynomials in the numerator and denominators. Okay? So let's actually look at an example. Let's imagine we have g of x, and we have the function 2 over x plus 3. So looking at this, I'm trying to figure out what was done to 1 over x to get to this function. So I might think, let's take the 2 out. Okay. And I notice now that if 1 over x is my original function, that really, again, if this was our f of x, really I took 2, multiplied it by f of x plus 3. So verbally, what we're saying is we have we multiply by 2, so we have a vertically stretched by a factor of 2, and shifted. So we're thinking either up, down, left, or right, being applied on the inside of our function. We're going left and right. This would be left 3 units. So we're looking at the function and trying to break it down into something that kind of gets us looking at the original. Let's look at another. So let's say we have h of x. 3x minus 7 divided by x minus 2. And I'm thinking of this, and maybe there's a shift to the right of 2, maybe, but this 3x minus 7 makes it a little unclear. So I want to say it's unknown by the initial appearance. It's unknown what's going on. So when that's the case, I encourage you to begin investigating this equation by dividing. So we're going to divide 3x minus 7 by x minus 2. And as a result, what we see is, 3x, we multiply by 3. 3 times negative 2 is negative 6, and we subtract, so that 3x's cancel. Negative 7 plus 6 would be negative 1. Okay, so we have a remainder of negative 1. So I'm going to rewrite my function as 3 minus 1 over x minus 2. Okay? Now I see something similar to 1 over x. So now I'm going to rewrite this again. I'm going to put my negative 1 over x minus 2 and my plus 3, so simply switch the order. Because I see this as negative, f of x minus 2, and we added a 3 on the outside. So looking at all of this, we multiplied by a negative, so that gives us a reflection. Over the x-axis. And then I see that we had a minus 2 on the inside of our function, so that gives us a shift of right, going right 2 units. And adding 3 on the outside of our function, we're shifting up that amount. Okay? So something that really was unclear at the beginning, through division, gave us a new appearance that allowed us to compare it to 1 over x. So, really there's nothing more than that. If you can't tell from the basic appearance, divide the two polynomials. Again, they're going to be linear polynomials, as we said before. Divide the two to get something that appears that's close to 1 over x, and examine it that way. So I have one example for you to try on your own before coming into class. So let's say that we have a function g of x, and let's have a function 1 minus 7x divided by x plus 5. Okay? So I encourage you just to go through and decide whether or not you need to actually divide these two polynomials to get a better look at what's going on. But once you decide, whether to not divide or divide, tell me what was done to, remember f of x is still 1 over x. What was done to 1 over x to get to this function? Okay? So post questions, comments in the classroom, and we'll go from there.